Hi, everyone. So we're about to get started. I just want to give you a little bit of an introduction to what we're going to be doing tonight and what Rangle is. So my name is Beth, and I'm the marketing coordinator. And basically, at Rangle, I help organize events like these. And events like these are really important to Rangle. We're a software, basically consultancy. We build custom software, and we're really focused on like customer-centric experiences. But we're also really focused on like collaborating with our community and learning along with our community. So if you learn anything tonight, I would really like to see what you learn on Twitter. If you would just tweet hashtag, like whatever you learn, and hashtag learn with Rangle. That would really help me out. I'd love to see what you're learning. I also want to introduce someone that we have here from Atlanta. His name is Justin, and he's here from Render ATL. He's for event, and he wants to say something to you.
How's everybody doing tonight? Like she said, my name is Justin Samuels. I came a long way today. I'm so tired right now. But I'm up here from ATL, outside of the U.S. in the lovely state of Georgia. Here on behalf, I heard a woohoo somewhere over there. There we go. I run a conference called Render ATL, which is the largest React JavaScript conference on the East Coast of U.S. But one of my partners run what's called NGATL and Node ATL. Has anybody heard of that at all? NGATL and Node ATL? See some hands. Okay, there we go. So it is a 5-day conference that is comprised of everything Angular and everything Node combined into one major conference. So some of the names that have spoken there in the past include John Papa. Does anybody know who John Papa is? People know? Okay, great. I see head nods now. Thank God. Okay, so he gave me today 10 whole tickets to hand out. So the tickets usually go for $1,800 each. So I've given 5 to the lovely folks at Rangle over here, and I'm giving 5 out to the audience tonight. So if you're interested in coming, it's first come, first serve. There ain't no trivia questions or anything at all. I don't got time to be doing that, okay? So if you want to come, just come holler at me over here, or go see Beth, and she'll take down your first name, your last name, and your email address, and you got an $1,800 ticket for a 5-day conference. And that's it. And if you are wondering, it's in the middle of February. Our conference, Render ATL, is in the beginning of May 2020. That's it. Thank you.
Hello. Good. Yeah. Hello. Okay. Good evening, everyone. Welcome to the new AngularTO meetup. So my name is Sumit. So we're going to talk about Angular IV and what it is, how we're going to talk about the new rendering engine. So my name is Sumit. I'm a solutions architect at Rangle. I have been at Rangle since 5 years. I've been working in Angular since the release of AngularJS way back. I love open source. I've contributed to Augury, Angular CLI, and the latest Rxjs docs, if you have seen that. I love minions, that's why they're here. They're one of my favorite characters from the animations. So why we are here? We're going to talk about what IV is, why we need IV, how it works, its internals, and we'll see some examples of how you can use it IV now. Let's get started. But before we dive into the IV, one of the most important questions that we have is we're talking about the IV is the new rendering engine and all that stuff, but what rendering engine itself is? So let me step back and answer that question first. So rendering engine is basically something that takes the code that you have written, compiles it, and then displays that in the browser itself. You can just consider them as a set of instructions to display that on your browser. Now in context of Angular framework, you write components and the code within your classes. So what Angular does is it compiles your code and then outputs a DOM. And then the rendering engine is responsible for using the compiled code and displaying that in the browser itself. Now, Angular has done 3 iterations of a rendering engine since its updated release of Angular 2. The first one being the template engine, which was released as a part of Angular compiler in Angular 2. The next one is the view engine, which was released in Angular 4. Now, it was updated due to some issues around the performance and the optimizations. And now the latest and greatest is the Ivy, which streamlines the rendering engine a lot and has other capabilities around tree shaking, dynamic component, and higher order components. So we'll go over some of those one by one. So even before that, so why Ivy, why it was required, and why Angular team think about that itself, right? So to answer that question, so whenever we visit a web page, right, we download HTML, we download CSS, and then the JavaScript. And by far, the JavaScript is the costliest of all of them, right? And then browser has to download it, parse it, and execute it even before sometimes displaying any web page. So if you're creating a fully featured Angular web page, it needs to download all your bundles and then display it in the browser itself. Now, it's even harder on the mobile because of memory and CPU utilization, right? And because of that small CPU and small rendering time, the execution time to display is even smaller. So when Angular team was thinking about what to do next, right? The goal that they had in mind was to make a rendering engine which is small, optimal, and that can perform well on slow end devices. So their main goal was to make a rendering engine which is smaller in size, faster in rendering, and it is easier to reason about. Smaller, basically making use of technologies like tree shaking, removing unused code and making the bundle size as small as possible, faster execution of the rendering engine so that it can have the less load times even on your small devices, mobiles or itself, and easier because as Angular developers, we have seen all weird stack trace errors in Angular itself. So there was asked by the Angular community to get rid of those and have easier, understandable stack traces. So that was one of the reasons also to make it easier and more optimal to reason about. So these were the 3 main goals. We'll go over each of these one by one. So what Ivy is now. So you understand what rendering engine is, what were the problems. Now let's come to Ivy. So what Ivy is? Ivy is the next generation of rendering engine in the Angular framework itself. It takes the templates that you have written and the components you have written, compile them to a HTML and JavaScript, which gets inlined, and then it displays it in the browser itself. It solves some of the problems that Angular developer used to face regularly about components not being tree shakeable, bundle sizes are large, and some other aspects of that. And also the stack traces I mentioned. So these are the few also, again, when Angular team was thinking about this, so they also thought about how they can do tree shakeable. So that's also one of the advantages of the new rendering engine. So what Ivy is basically, it creates a series of instructions that you can use and display in the browser itself. We'll go over all of these slowly. So before Ivy, let's see how Angular currently renders your application itself and the component in the current template engine. So currently we have a template. Whenever you write a component, you write a template HTML and the component class itself. Angular, what Angular compiler does it converts your template and your component in a highly optimized JavaScript, which is then passed to an Angular interpreter at runtime, which takes the data that you have and then displays it in the browser itself. So you can already see it's a lot of code, right? And a lot of steps to render something. Now, how Renderer2 does it, it's basically it creates two files for each of your component. One is the JS file, which is the compiled JavaScript for your component, and the second one is the factory file. Now, the factory file is basically your compiled template that you have written in a separate, it could be in a separate HTML or it could be in an inline HTML within the component, but it still generates two files for that. Now you can already see there's like a lot going on under the hood, right? So it generates the files and then Angular compiler needs to know about both of these files for a particular component and then reference them reference them back and forth during the data binding if something changes a lot. So it was a lot, right? So Ivy simplifies it a lot, by inlining the template that you have written within your component files itself. So now if you write the component HTML and the component TypeScript, what I will do is it's basically compile it into one JavaScript file which contains the information about the template as well as the component that you have written. Now how it does that, right? Because you were already writing the components earlier, you are also writing the components in the same fashion, right? So how does Ivy know how to do that? So Ivy has introduced few fields which are basically statically defined on each of your component. So @ component becomes the ng component definition on the component classes itself. And so it makes use of define component. So you see those two thetas, it means it's a private function within your Angular compiler itself. Directive becomes ng directive, pipe becomes ng pipe, and so on. So I'll show you the example of a few of those as we proceed. So let's see the example of a component and how it compiles and renders in the Ivy. So if you see, here's a component. It's a basic component where I have a template which displays a title in h1 tag, and the title is hello Ivy, right? Now, when it gets compiled within the Ivy itself, it generates something similar to this. So you can see this is basically a wrapper function that is compiled by Ivy itself, and it contains all the information about the component as well as the templates. So we start with, so we can go over it one by one slowly. So this is basically the functional representation of the class that I created. And then you can see the component definition property that was added to my class itself. And it is making use of the define component function itself. So what it is telling Angular compiler is basically I want to create a component which is of type app component using this as a selector and a factory function which is defined in the template itself. Now, it might be confusing at a start, but I will show you how you can create those easily. Constant varies are basically variables that are defined by the compiler itself. So they represent the something Angular calls the L view or a T view. What they do is basically they keep the references of the multiple components that you have. We won't be going into the details about that here, but it's just the constants that are referred by the Angular compiler itself. And then the next is basically the template function you see over here, and then encapsulation. Now, as I mentioned, Ivy has done a lot of improvement on the rendering capabilities itself. So now let's see how it has changed from the existing templates to the new templates. So now in Ivy, every component or the template is represented as a set of instructions. So you have two sets of instructions, one to update, one to create the DOM nodes, and another one is to update the DOM nodes. So the first if block is basically to create the component. The second block is basically the update one. You can say it's like on create and on update in the current context. Now, what Ivy does is it creates instructions for each and every element that you define within your component. So if you, now in our case, we have defined an h1 tag. So it's saying, compiler, I'm going to start defining my component and start with the 0th element, which is an h1, because initially at the start we don't have anything. Then it says at index 1 write a text, and then end is basically the closing of the tag, which is the closing of the h1. And then the next is basically this update command, where it defines the binding. So where if there's an update to the text, what it does is, hey compiler, go to the first node within your render tree, which is text, and then apply the title on the component itself. I know it's a lot. Let's see an example in working. Then it would be more clear. So let me start with an example that I already have. Okay. So we have the can everyone see it clearly at the, okay, perfect. Okay, so we have a component as I defined here, right? Now let's assume we want to wrap this h1 within a div, right? So what I'm going to do is I'm going to add a div tag, right? And then I have h1 and title. Now, as I told, Angular creates instruction sets for each and everything, right? Now here, initially I had 2 nodes, now I have 3 nodes. So div is at 0th index, h1 is at 1, and the title is at 3rd index, right? So if I go and compile this, you will see instruction set with 5 instructions, starting div, starting h1, then inserting the title, ending h1 tag, and ending the div tag. So Angular, so if I want to compile it, I will say yarn ngc, which is basically compiling the component that I have into the TypeScript files itself. And let's see the output over here. So this app components, and then the hello component. I'm just going to format so everyone can see. So so you can see like Angular generated the ng component def on my hello component. Now this is the example I showed is an ES5, this is ES6 representation of that, but the concept is same. So it created a class, and then it defined an ng component def using the define component. I said like, hey, the type is the component above I'm using. These are the selectors. As I told, the const is basically the number of tree nodes that I have within my component, and as it represents the bindings, it will get changed as you add more bindings and more components. Now, as you can see, as I told, like, compiler, what it did was it created the element at the 0th index, which is div, h1 at the first, then text, and then ended both of that. So you can already see it's a lot easier to reason about, and we can even set the breakpoints when we are debugging the application itself. And then this is basically the same code because we only have one binding in the component itself. So it's saying, okay, hey, but one thing you see is different. In this example, I had the text note at index 1, but now since I have moved it at the inner level within my component tree, you see the index which has generated is basically 2. And I can run it as it is, and it should because I'm making use of this component. One second. In my HTML as a app hello, and it you can see it display. So this is the first component that I have. It's pretty straightforward. You all know, you all do it right in these days. Now, wouldn't it be great if you can generate the component by yourself instead of compiler generating it for you, right? So let's see an example of that. For the sake of time, I already so let me minimize a bit. So now what I'm doing, let me just get rid of this. This is another example that I want to show, but before that, let me explain. So now what I'm doing is I'm doing the same thing that Angular compiler is doing, but I am doing it manually on my own. So what I am telling Angular, hey, I want to create an hello IV component, and then as I told, like Angular creates a static definition, static properties within the component itself. So I'm creating a static property ng component diff. Remember, you have to keep the names the same, else it won't work, because Angular compiler is expecting the property with the ng component def name itself. I'm taking now all these functions, the define component, the define pipe, are private to the Angular compiler, the core itself. So basically what I'm doing is I'm importing the core as star, and then I'm referencing each and every function. So what I tell Angular compiler, hey, I want to create a component hello IV which is of type this. I want to keep the selector as this. Const is basically, again, as I told, it's an LView property. You can use it, but now I'm going to add 5 nodes to my component itself. So I've defined the property 5. Variables is the binding itself. Factory is just the new representation of the class that you have already defined. Inputs is basically, so this is the representation of how you define the inputs and outputs in the component itself. And then this here, so now, as I told, there were 2 if blocks. One is for the creation and one is for updation. So whenever you're going to create the dynamic components, you will see those here where I'm telling Angular compiler, hey, this first block is for creating the component, and the second block is to update. And then I wrote the instructions for creating the component, where it's basically, I'm going to start with the div, then h1, and then there's a text that is going to be in the h1 tag. I'm going to end the first h1, going to add button inside it, and then I'm going to add a listener to the button itself. So you can already see it's a lot easier and it's a lot more declarative than initially it used to be, and you have more granular control on the things that Angular compiler is doing under the hood, right? So it does that. We ended that all. And then if you want to make use of the component itself, so what you need to do is, one of the other important thing of this is you don't even need to declare this component within your ng module itself. You can directly use it. Again, there are caveats for that, but you can do that. So now I import the IV component in my app component, and then what I do is basically I tell, hey Angular, okay, I have this component, now go and render it within my div. So host is basically the container that I'm going to use to render this component on this. So it's basically, it's an empty div here, right? It has. So what Angular will do is Angular will take the component that I've created and add it to the app hello world itself. And it's already, so you can where is my app component? So I save it and then you can see. So this is dynamically created component that I have, right? So if I have to change something, I will. So there, and then you should see. Oh, so you should see like this. Sorry. This was the second one. So you should see that component already reflected here itself. So you can create all the components by yourself also. Let's continue. So you can already see the power of Angular, Angular's new rendering engine. Now, as I mentioned, so Ivy uses instruction sets, and it has instruction sets to basically create, update, and manipulate the DOM to do the data binding, applying styles, and each and every aspect of that. Now, one of the most important advantages of using Ivy is the capability to tree shake. Initially, since Angular as I showed, right, it generated different files for the template as well as the component itself, and it needs to do the it needs to do the binding between each of those. So it was really hard for the compiler to do the tree shake. But with the new instruction set, say if you are not using a function, you don't have to. Angular core will not include it within the release build itself. So it gives you a lot of advantages when you are doing the tree shaking. So to give you an example how it is doing currently, let's take the example that we already have. So we already see we have a div which has an h1 tag in itself. Now in the current Renderer2, how Angular does it, it's basically it creates view definitions and element definitions for each and every component that you have. View definition being the Angular component itself, and the element definition for each and every element which is defined within your component, starting with div first, then h1, and then the hello world. Now, so this is generated by the Angular compiler itself. Now at runtime, what Angular interpreter needs to do is basically it needs to mix and it needs to match all of these definitions with their implementations. And so what Angular had currently in the Renderer2 is basically a huge switch case where it goes over each and every node and displays that appropriately, right? Now you can already imagine how this code being shipped to all of your bundles, even if you are not making use of, say, pipes itself or the type, because interpreter doesn't know if you are going to use pipes or not. So Ivy, again, as I mentioned, simplifies it a lot with each and every component template depicting them as set of instructions. So if I'm not making use of, say, the text property, Angular compiler will strip down the text property and it will not include that in my final bundle itself. So I mentioned about how the Angular is faster, how Angular is simpler and tree shakeable, but there's one more important property in the Angular introduces in the IV, which is basically locality. Locality is something, so a lot before IV, if you have a large Angular project, right, it used to take a while to compile that. So the Angular IV introduces a new principle called locality, which says you only compile the file you have changed, you don't compile the whole project if there is a change in itself. Now, how Angular does it is basically, let's see an example. So imagine a component tree where you have the root, you have the parents, and then you have the child nodes in itself. And you are going to change one of the components only, not the whole tree itself. Now, in the previous examples, as I shown, right? So Angular does have the representation of the childs within the parents itself. So when Render2 compiled it, it needs to reference the parent as a child, as well as the childs to compile and regenerate the code. In IV, due to the locality principle and moving the templates within the components itself, what it did was, it's basically you only need to compile the component itself. You don't need to worry about anything else right? To give you an example, if you want to just update the element start, right, and override it with your own implementation, you don't need to compile the hello IV or hello world component itself, because you only need to compile the implementation, but not the function itself. So IV simplifies it a lot. So as I've talked, like with the new instruction sets, Angular does display stack traces more clearly, so you can clearly see what has broken and in which line within the components itself. Another advantage of Angular IV is basically the dynamic component loading. So you can load the components on the fly and then render them within your Angular application. So let's see an example for this. So this is my regular Angular component, which I have created and then giving it a name as a dynamic component and the title and all that stuff. I have a service in here also, and then a function which basically changes the title to an uppercase and then put it in the component itself. So now to display that, what I've done is basically I've created a dynamic host, which you can consider it as a container. So at runtime, what Angular will do is Angular will replace my dynamic host with the new component that I'm going to load. So at runtime, what it does is, what I'm telling Angular is, hey Angular, go and import the new component that I have already created. Once you have loaded it, then go and render that component in my host itself. Now there are few things that you need to consider. I will go or keep in mind, I'll go over those one by one. So once you have done it, you can see this dynamic component getting loaded within my and getting rendered in the on the page itself. Now if I change something, it goes away because there's no component in my page which is saying like, hey, I need to replace this with the dynamic. I need to replace this tag and render the component itself. So the host name should match the tag you want to replace within the component. So if I do this thing, and you should see the component is back, right? So the host name should be the same that the tag you have defined in your HTML itself. Now, okay, we have rendered the component, but how about the functions like ng on init, ng on destroy? So to make use of that, you need to tell the compiler that, hey, this is the component that I'm going to initialize, add all the lifecycle hooks for that component within. So Angular has this feature called, or a property called host features, where you can tell Angular, okay, what all features you need to use for this particular component. In here, I'm using the lifecycle hook features. Now, if I go to my dynamic component, you can see I have this ng on in it, which says initialize dynamic component. And when in here, you can see the initialized dynamic component is getting rendered. This is because I have told Angular to make use of this feature. Now, if I comment this out and go and see, you can see like the component is getting rendered, but it's not hooking up into the Angular's lifecycle. So you just have to keep in mind some of these gotchas when you are dealing with the dynamic component loading. And it's the same when you are trying to create the components on your own. So you have to provide some of the high lifecycle hooks and properties. So I'm going to put it back. Another important thing that you need to keep in mind is the detect changes. So by default, when you load a component and you click or you do something, Angular compiler doesn't know what to do until you specifically tell Angular that, hey, I have done something, go and make those changes, or basically, hey, Zone.js, go and detect the changes itself. So to do that, whenever you have to create the dynamic components, how you can do is basically, again, there's a method called detect changes, and in the code itself, you are familiar with that. So whenever you're doing something in the dynamic component, you have to explicitly tell the compiler that you have done something and go and detect changes. There are other functions like mark as dirty, touched. You can also utilize those depending on the use case itself. So now if I go and click, you can see it gets changed to the dummy text. Actually, the last thing I wanted to mention is the injector itself, right? Now, a lot of times we need to inject services within the components itself. So you need to tell the dynamic components that you have loaded about the injectors also. So for that, Angular provides the injector property on each and every component itself. So you can tell the dynamic component, hey, go and make use of the injector that my parent component have, and then use it. So as I show, so dynamic component is making use of fake service, which basically go and takes the string and just converts it to an uppercase. Now, if I remove the injector from the component, Angular will throw an error saying it can't find the fake service because, yes, I have rendered it, I have displayed it, I have told it to detect changes, but I have not told it where to go and find the initialization of the fake service itself, right? Because the services are initialized within the Angular modules, and I'm making use of, I have initialized it in my app module itself. So I need to tell the dynamic component that I'm going to make use of fake service, which is on my parent component, go and use the injector tree and reference the fake service itself. So to do that, basically I tell my new component, hey, go and make use of the injector that my parent component has so that it can refer the fake service through the hierarchy. And as you have seen, so if I go and then click on the title, it is able to find the fake service, take that string and then convert it to the uppercase. So another thing that I have already shown is basically the simplified bootstrapping. You can render your components without including the framework code itself. You just need to tell the Angular compiler that, hey, you want to render a particular component. But you have to keep in mind, this is only useful if you want to display static components. If you want to use services or injectors, you would have to use the ng module itself. So if you only want to render an HTML using Angular, you don't even need to include the Angular bootstrap code within your basically within your application itself. So these basically, once you have created the hello IV component, these are the 3 lines only that you need to use to display that on the browser itself, without app module, without main.ts and all that stuff. So now the question is how you can use it is basically Angular CLI is a flag called enable IV that was introduced, I guess, in 8th version of Angular CLI. So if you want to use the IV on the new project, you can just say enable IV, and it will create the project keeping IV in mind and putting that flag in the TS config itself. So Angular CLI will add enable IV flag in your TS config. If you want to use on the existing project, you can basically manually tweak that and add that on the component itself. So we've already talked about this. So basically, these are the other advantages of using Angular IVs, basically smaller build, quick rebuild times, faster developments. It has a simplified pipeline, and the code about the templates is more human readable. It's more to reason about. There were few more examples I wanted to show before I wrap up. So again, with all these instruction sets and everything, Angular IV also enables you to create higher order components. So basically, you create a decorator function that you can put within in each of your components and then use that. So I have an example of that. So I've created this higher order function. Now we were using titles in all of my examples. So I just made a higher order component which adds higher if we are using using this function or not. So what it does is, what higher order function does, it's basically it takes the component that you are referencing, go and take its references its instance. Now in this scenario, it checks if that instance has a title property on it, it goes and appends an higher and that, and then and the next set of instruction is basically I'm telling it, hey, I want to override the ng on it. So imagine you have a app where you want to know, okay, how many components are getting initialized or destroyed when you change views or something like that. So you can create higher order component to basically log on init, on create, on destroy methods, and then use them. So once you have created the function, how you can use is basically you have to go to the component that you want to use. And import that higher order component, and then add that annotation for that saying, hey, I want to use it. And so whenever you create a component, whatever title this underlining component is passing you, just go and override it and then append a higher in that. So if let's see an example for that. So I have this hello world component, and you can already see it has already appended higher at the start. If I go and strip that higher order component, you should see like it has removed the higher. And then if I bring it back, it prefixes the higher within my title itself. So you can already see the power of like how streamlined the Angular IB is, and how you can utilize to basically create the dynamic components, create your higher order components, and also to streamline the rendering pipeline that in each of your components itself. Yeah, so these are basically the advantages of IB. I've already told, like the smaller builds, it has quick rebuild times because of all the instruction set pipeline that Angular IB provides, faster development with the locality principle where it only compiles the file that it is referencing, not the whole application itself. Simplified pipeline about the instruction sets and how you can use it, and then the human readable form. Thank you. Any questions you have? Do you mean the compile or the rendering? I'm not sure about that. It's like, I don't have the benchmarks from Angular. So the Angular team might have some metrics. I would have to look into that, but I'm not, like, I don't know, remember that.
Would you recommend upgrading to 8 just to use Ivy, or?
I would recommend that because again, with all the advantages that it provides, also tree shaking, tree shaking is one of the advantages that it has, right? So it would drastically reduce, not drastically, but at least reduce your bundle size, maybe 5-10% something. Again, it depends on how you have structured your application itself, right? So it does tree shaking, but it's again, there are caveats around that, how you're using it. If you're already if you have modular application, you are already lazy loading all the routes, you might not see that much difference, but if you're bundling everything in one, there would be changes.
I didn't understand exactly tree shakeable. Is this like something like tree handshake, or what is it for?
So tree shakeable is basically the code that you are not using. Angular will not compile it in your output bundle. Okay. Or it's basically the general principle.
And my other question is, like, this is something like Flutter, like Dart, like Flutter and React. Like they try to get something from Dart. I mean, Flutter try to get something from React. They try to like mix them together. Is it
maybe? I'm not sure about that.
Like
It's like how? So what was there?
I was reading like incremental.
Yeah, so they have
ROM.
Yeah.
DOM. It's just something like a state. They are watching the state, and if the state change, like stateful, something like stateful.
No, so incremental DOM is basically they're only looking in. So when Ivy generates the instruction sets, say you have 10 instructions, right? So when you make a change, they compare the instructions and only apply the change, like only call the function for the changed instruction rather than calling all that. Right, so that is basically the incremental DOM.
Stateful. It's like in the Flutter, it is stateful. Like I was looking also.
Maybe, yeah, I'm not aware of the Flutter. Yeah, so could be that because they use something called, as I mentioned, the LView and tree view to keep the internal representation of that, and then reference that, and then apply the changes on the components or the DOM tree. You can say that. You should upgrade, but I haven't seen much. Again, there are certain caveats about the dynamic components and how they are rendered now versus how render 2 renders them. So whenever if you are going to upgrade, just make sure you watch for all these things, right? So in the examples that I shown, it's like, about the detect changes, passing all the providers to the components itself, right? If you are going to use the view renderer, and because Angular Ivy is backward compatible, right? So if you are not going to make the changes, a lot of changes, just use the compiler for tree shaking. You can still use that.
Hey.
Hey, sorry, can we use the mics for questioning, please?
Okay.
Hey, great talk. So I was just wondering, like, we've already had tree shaking in the past with, like, Webpack. My understanding, and correct me if I'm wrong, is that here you're tree shaking the engine itself, right? So you're basically saying, if we don't use this type of node, then we don't need to include the functions to render that type of node. Is that correct?
Yes.
Okay, and just to follow up on that then, so does that mean that when you do use dynamic components, that host features property that you mentioned, you would have to specify, okay, I know I didn't have text components in my initial bundle, but I'm gonna have them in this dynamic component. So is that something you would specify in there? Or is that not the use case for that?
No, I don't think it's the use case for that. I might be wrong, but it's only tree shaking the instruction set. It's not tree shaking the actual output. So in your case, it will just say, okay, hey, I have this element, and just go and render it. But the actual implementation of element, if it's included, it will render. If not, it won't do anything.
Okay.
Right. I still have to explore a lot of those things, but I just know the principles.
Thank you. So I just feel very interested in the higher order component. Is that to saying that if I want to create a different button component, I can just, instead of extend the other component or the other class, I can just use the higher order component to do that?
Yes, but there are certain caveats. It's like you can't just say extend that component, implement that in here. So how Angular does it's a bit different. It's like you have to create a function to manipulate the existing component, but you can't create a new component out of that. So you can use it to change the component behavior, right? And that's what I'm doing over here. See, again, there might be, since I was still in development, right? I think they are not released it, but in here, what I'm using is I'm just modifying the existing components, but I'm not or you can say but I'm not creating new components out of that. In the example itself. It would be good to test that, but I haven't explored that possibility yet.
Hello, thank you for a good talk and explanation about internals that goes on in Angular. But my question about, did you use Ivy in production or any project that bigger than Hello World?
Oh,
And
yeah.
what is
So
your experience about
there are a few projects that we are already upgrading to Ivy. They are still in process, but we haven't released that in production.
how big they are?
They're quite big.
Can you approximately more than 1,000 component, less than 100 components?
It's probably less than 1,000, but maybe somewhere around 200 or 400. It has a lot of dynamic, dynamic components. So it's like they are generated
can
on
you
the
share
fly.
what kind of problem did you get? Maybe there's problem with element ref, maybe with render.
So as I told, like we are still in the process of doing that.
But for now, do you have any problems to migrate on the Ivy?
So one of the problems that we faced was around just like referencing the elements in the new renderer. So
Element ref, you mean that in
Yeah.
all technique we'll use?
Right. So we extensively use the element ref, which gave us, I don't remember out of the box, but we had some problems doing that.
What's about injecting? In Angular 7, we can inject element, parent element, like use injector, these optional things. What's about new
So
Ivy?
you can still use that, right?
It works
So
still
yeah,
the
yeah,
same.
it works. So Ivy is fully backward compatible. It's like if you don't want to use it, you can just use the compiler, and it should work. Apart from few like things about the renderer and everything, but other than that, it should work itself.
Thank you very much.
So,
Thank you for the talk. I was wondering if the only improvement is tree shakeability in the renderer. Did you gain any build size reductions using Ivy on ahead of time compiled applications?
I haven't done that yet. We're still in the process of upgrading, so
Okay, thank you.
yeah.
Sorry, just a really quick question. Have you tested this in Angular 9 since the next versions are already available? The element ref has changed, so the access is somewhat limited. So have you guys tested that?
No, I haven't tested that yet. We're still working on 8.
Okay.
Yep. But yes, it's a good, we should do that.
Hey again, just a quick one. So one way of reducing the amount of JavaScript you send to the client is to use server-side rendering, for example, Angular Universal.
Yep.
So I'm just wondering with Ivy, does Angular Universal still work with Ivy out of the box? And two, then does it compile the templates with the incremental, with the instruction sets on the server and then still send the rendered HTML to the client? Or how does that work now?
It should do that, but I haven't like explored, to be honest. It's like I'm still exploring all the ins and outs from the like just in time build and all that.
Yeah,
But
sorry
not-
if we're pushing you too hard.
Yeah, sure. Okay, thank you.